Thank you, Tom. Good afternoon, everyone. I'm Sumithra Bhojan with AT&T. I come from the access network part of the business, like Tom Anschwitz. So today I'm going to be, I think I'll wait for the, yes. I guess we'll have to wait for it to refresh. But today I'm going to be presenting open access, a view of AT&T's view of open access. And let me kind of just give a little bit of basics on what is access, right? It is the last mile of the network that attaches a subscriber or a customer to the network side, to the telco. Okay. Anyway, so it basically consists of like access nodes that typically sits in a central office, or it could be on a, sorry about that. I think we haven't been able to refresh.
We have an air gap.
Oh, wait, this one. Here, at the back. Sorry about that. No.
Did this flash?
Yeah, now I think.
Okay, and I just hit.
Yep, got it.
Yeah, we got everything.
Yep. Right.
There you go. Now you got
Okay,
it.
thank you. So I guess just going back to, what is open access. So I'm going to be talking about the network devices that typically sits in a central office or in a remote location. And at the customer side, you have the, customer terminating devices, both connected via either fiber or copper, right? So we'll touch upon some of the fiber technologies like the XPON and copper, such as the GFAST technology. In XPON, we do have GPON, which is a symmetric 1 gig service, and XGS-PON that provides symmetrical 10 gig service. And I'm going to start off with the more of a view of the architecture. So that will give a good perspective of what we do in OCP and how it fits into the implementation or the deployment at telcos. Starting from the bottom, if you look at the right side, the picture, that's the white box OCP hardware that we design at the OCP. You will see for XPON, we have the OLT or the G.fast, and it can be any access devices. In OCP, we have been active. AT&T has been contributing, and the key member is Tom Anschwitz. He's been leading our specs, had a couple successful approved OCP hardware out there. And we are continuing to contribute more specifications or designs for the other technologies as well. And the goal here is to have a completely disaggregated model, right? Hardware and the software. Moving up one stack into the green box, you will see what we call the open source access manager abstraction, hardware abstraction. It's pronounced as awesome, just like the project is. It's widely or popularly known as Volta. You may be, some of you may be involved in the Volta project with ONF community. So it's a software, it's a hardware abstraction of the access devices. It pretty much hides the complexity of the device, the protocols, and it provides a uniform way to access your device from the northbound controller as well as the management. So I think that's truly a game changer, and we have had very successful engagement with the community in ONF. Several operators and vendors are very much involved in developing that open source software. And going one level up is the disaggregation of the control and management. So where you can have a number of VNFs, access-related VNFs, hosted in the controllers. If you look at what we have today in the legacy system, right, you can kind of compare that to a combination of the green box and the white box. So that is all. It's kind of it's a proprietary hardware that we have today, and the way we have disaggregated is by the different pieces and how it all fits into the architecture. And moving up north to the blue box that's the open source access manager. It's vendor agnostic operational suite that helps you manage your underlying access network and the services. And we are working with the ONAP community on that. We kicked off a project late last year. Right now it's being developed as a use case for the next release, which is the Casablanca or the release 3 in ONAP. So this kind of provides a view of how a telco could take it to the field, using all of the open source hardware and the open software. Okay. Next, we'll cover some of the designs we have out here at the OCP. On the XPON specification, I think it was September of last year, we kind of did a proposal on FPGA-based design. We do have XGS OLT box out there. You might have seen it in the booth. EdgeCore has a box. So our goal is to kind of, what does our future look like? We want to future-proof it for the next generation of the PON technology as well. So we're going to start with a 24-port programmable PON OLT. And we also have an open fiber distribution hub. That's more of a passive device that is in the outside plant. Let's look at some of the, how do we use FPGA in the OCP telco here. I think last time when we did the proposal kicked off, there were a lot of discussions about, how does it benefit, right? Because FPGAs are not quite the same as ASIC, but it can be. The critical piece is the IP core. Without the use of IP core, you can't really make use of the design as such. So since then, we have had very successful engagement with several FPGA vendors as well as IP core providers. And we have had very positive feedback in the commitment or the willingness to have an open IP core model being available to the OCP community. So that way, the ODMs will have access to the IP core in producing in the hardware or the boxes. Kind of looking at a model, I think it could be very similar to the ASIC, And when you're looking at FPGAs, it's always, meaning it has to be driven by volume, right? That will make the economics favorable for us. So I guess by going with a standard IP core that is made available for the particular OCP spec would make it more economical. Obviously, with FPGAs, we do have the flexibility to customize if you would need it. So you do have that option to customize. But I think having a standard IP core would be a good model here. The spec that we're looking to work with several collaborators are the 10 gig and the 20, like I said, the future 25 gig PON. You may have seen IEEE is already working on the 25 gig standards. So at this point, when we do a hardware, we want a little bit more longer life, so that way we can reuse the hardware. If you look at, so that's one of the differentiator between what we have today and the way we see this box. So support for the 25 gig and also increase the port density. That's always been a challenge. So at least have 24 ports. That's the critical requirement. And we kind of looking at a few options. I would like to get feedback from operators or vendors here. We could talk offline too. what is an optimal design, whether we could go down the path of a similar approach we have with the XGS box, the 19-inch 1RU, or in the morning sessions, a gentleman from Adlink and Redis's, they talked quite a bit about the CG Open Rack 19. And I mean, that is definitely a good model. It's certainly makes it easier to roll into a central office. It's kind of like a pod design, if you will. So we can, looking at both, if we can fit it into like an open sled design where you can reuse a lot of the common components, and then for the OLT, I think that would be a good option as well. So we're looking at both, and I welcome any feedback on this subject. The goal here is for us to have a spec detailed design probably in the next couple of months. I think that would be a good target. So I kind of encourage any feedback, or if you would like to work on the design, please let me know. Now, going into the Open Fiber Distribution Hub, this is being authored by my colleague, Earl Pope. Unfortunately, he couldn't be here, so I'm just, I would like to introduce this spec as well. There's a lot of updates that have happened in the last couple of weeks. I know we we talked about it on the last month's call as well. This is pretty much it's a passive device with fiber connectors. So you would have the feeder cable from the central office and the distribution fiber to the customer side with splitter modules. So it's more of the fiber connects that goes in an outside plant. So like I said, this is I think it's in a pretty good shape. Welcome any feedback, and I think he was looking at closing the design in the next month as well. Okay. And now let's move on to the GFAST specification. So we do have a detailed spec out there, or the design out there for the 16-port DPU. We do have a design with the Broadcom silicon as well as the Scipio silicon. 16-port has kind of been a sweet spot for MDU type of applications. GFAST is a technology that provides fiber-like service, right? In the first generation, we're getting kind of, I wouldn't say like 1 gig, but then it's close. You can do up to like 500 to 750 meg service. And with the second gen GFAST, it goes all the way to 1 gig symmetric service or an aggregate of 1.5 gig. So it's pretty good, comparable service to a fiber. So this is the kind of a block diagram of the 16-port DPU with the Broadcom design. In our deployment scenario, it includes using both the coax and the twisted pair medium. And also one of the key requirements here was the reverse power feed. Reverse power feed is something that you could use the power from the customer to power up the DPU box. The critical piece here is, with just one customer line, you would have to power up the box. So that's the challenge, and we've been working with. With the second gen, it's been power efficient. A lot of testing is happening. The goal is that, this design would be well suited for the reverse power design. And the uplinks, typically, it can do 1 gig, 2.5, or a 10 gig. I think typically in a deployment scenario, you would find a use case for an XGS PON type environment. Okay. And this is a similar design with a Scipio silicon. Same requirements. It does both coax and twisted pair, as well as the reverse power feed. And both of these designs are, out in the, it's online in the telco website. I would encourage you all to kind of review and provide any feedback. We have received a few feedback, and I'll be making some updates to the specification. And the goal here is also to complete and get it approved in the next couple months. Okay. So that's my, request for feedback. Any questions? If not, thank you very much for your time.